Well, I think that that's definitely a direction for the future. I mean, our study was limited. We didn't look at so many. Regorafenib has been approved to treat liver cancer. It's already known to work. I know some of my colleagues around the country will occasionally talk about using Folfox to treat liver cancer. And so I couldn't tell you exactly why we didn't see that, but it wasn't a major focus. Like it didn't fall out as synergistic in the lines we looked at. That's not to say that there aren't situations where it might be. But liver cancer tends to be pretty angiogenic, but the microenvironment is also different in liver cancer, as well as liver metastases. So, it is complicated. So ultimately, I'm not sure I have a good answer to tell you that all liver cancer would be resistant, but it just didn't come out easily, in our early preliminary look at it. ALDH1 is a stem cell marker. I mean, that's really a little bit of a bottomless pit if you want to talk about stem cell markers or stem cells in general. But the idea, I think, with stem cells is they don't respond as well. And if you treat with a drug that enriches for them, this could be a sign that maybe the tumor appears to respond, but some cells which behave like stem cells will hang around and later come back and repopulate or cause progression of the disease. There's, a lot of controversies about what defines cancer stem cells. And years ago, I became interested in cancer stem cells, mostly operationally. As a medical oncologist, it's bad to have them. They're resistant to therapy. They pump drugs out. They have features that don't make them as sensitive to the usual cytotoxic agents that kill rapidly dividing cells. And so, we typically in our therapeutics research keep track of stem cell markers. And, if a drug increases stem cell markers, we would be looking for ways of overcoming that if we are working on synergistic combinations. So that's why we are looking at it. With stem cell markers, there's a lot of heterogeneity in terms of what they are, what has been reproducible, and how you characterize them and how you prove they're enriched. And there are different approaches to look at that. Some people do sphere assays, some people do flow cytometry, some people do markers. It isn't even clear at this point, if there are different entities as far as the stem cells that have different markers with this general biological behavior. But we've done some experiments years ago showing that 5FU definitely enriches for stem cells. If you culture colorectal tumor cells in the presence of 5FU, literally within 3 or 4 days, they start to become resistant and have features of cancer stem cells, which also tend to form spheres they're called colonospheres in that case, when they do this. So, the work on cancer stem cells continues to be in a work in progress. There are some companies out there such as Veristem in Boston, that has some efforts to target cancer stem cells. But I don't think there's anything approved. I would say in colorectal cancer, the Wnt pathway, which is a major driver, has effects on cancer stemness. and there really aren't any drugs targeting the Wnt pathway in the therapy of colorectal cancer either. So ERK1/2 and STAT can be they have kinase activities that can be inhibited. So, regorafenib is a kinase inhibitor. And the kinases you mentioned are pro-growth, pro-survival. Kinases that are active in proliferating cells within tumors. So targeting those kinases is certainly an active area. I think there are agents out there that are under investigation that are ERK inhibitors, ERK is part of the RAS MAP kinase pathway further down. And so, there's interest in inhibiting ERK kinases in cancer therapy. STAT3 and the stats in general are studied more and targeted more in hematologic malignancies, but they do show up in mechanisms in solid tumors. I think there's a lot of efforts to study their role and their targeting and their relevance to resistance mechanisms. I am trying to pursue bringing the combination into a clinical trial. It's a complicated area to navigate because we're talking about two approved drugs that are not being used clinically in combination. So, it's a matter of having the pharmaceutical companies agree to collaborate, which is often a challenge. But I do think, for example, you could say, well, TAS102 is already approved in combination with bevacizumab, which is an anti-angiogenic agent. So what could you possibly have to offer beyond that? And I would say regorafenib has a different profile, different anti-angiogenic profile from bevacizumab, and therefore it might be worth testing in combination, for the combination that we came up with, and certainly in other GI tumors. I think we'd have to do a little bit more with liver cancer to understand a bit more, is this resistance across the board, or is there a biomarker that might help us figure out who might respond? But yeah, I mean, I think it's a good combination to pursue because, and I would say it really shouldn't be that difficult to get this into clinical testing, just because of lots of safety data. I think we now also have learned about how to dose regorafenib in combination. So, regorafenib is approved or certainly has been tested in combination with ipi-nivo at a lower dose, 80 mg per day. And interestingly, there's some data out there to suggest that combo might be better, work better for people with lung metastases versus liver metastases. So, those things now are aspects of drug activity that we pay attention to and are interested in understanding, why is that? But clearly, the pattern of spread affects response to different combinations. And I would say beyond that combo, one may want to add additional drugs. But then you worry about toxicity. But some targeted agents or some available agents are not particularly toxic. So, there's potential there. I think there's a lot to be done with the science that's in our paper. I was really intrigued about what's going on with the BRAF effects and promoting endothelial cell growth and some vascularization. And not a whole lot is known about that, but I'm also glad that the combination of TAS and bevacizumab is approved, because I think whatever activity may be happening, in some settings, should be overcome by the addition of bevacizumab.